Hey there, Course 3 math students. You're here because you care, or maybe your parents forced you. I don't really know. But this is the bonus enrichment module on irrational numbers in geometry. And actually, this is a big chunk of Khan Academy. I'm gonna help you get through it. It's pretty fascinating too, and I hope you find it interesting. I'm gonna make 3 short videos, a little bit of lessons, and then you're going to have a kind of a project test. And again, these things can only help you. Whatever you do can only help. But more importantly, as far as being curious goes, learning these things, filling these holes in your understanding of the world are really important down the road. And students that don't get to this point are going to have a much harder time in geometry and trigonometry and in forever. It's something that you have to get through. You don't have to, but you should if you want to be a problem solver that has more skills. All right, enough of the background. Part 1, irrational numbers. So I have a square here, right? And it's 1 foot on one side, 1 foot, so 1 foot, on each side. So the area of that square is 1 square foot. 1 times 1. So the area formula for a square is the side squared. So you'd look over at this square and you'd say, well, this area is 4 square feet. The question is, how do you figure out what the sides are? Well, you're all like jumping out of your seats like, come on, it's 2. You know it's 2. But how did you get it? Right? If you divide 4 by 2, you get 2. If you divide 1 by 2, you get 1/2. So that doesn't work. So what you have to do is, in order to find the side length, you have to say, aha, we'll take the square root of the area and that will give you the side. So in this example, this would be like 4 square feet and that's 2, so I know each side is 2 feet. And that's really important because if you look down at my bottom square here, this square has an area of 5 square feet. And you better not tell me that each side length is 2.5. This problem also shows up when you look at volume. Again, the volume of a cube, we can really do it with any shape. The volume of the cube are the 3 sides multiplied together. So if this cube here has a volume of 1 cubic foot, you'd say, okay, well, each side is 1 foot long. Or if it had 8 cubic feet, you'd say, well, it'd be 2 feet long. But what if it had a volume of 10 cubic feet? So let's just go back a second and go through this. What we're really doing here is we're taking the square root of the area to find the side. So for this one here, it'd be like 5 feet square rooted. I would need my calculator. If I did these, of course, I'm not dividing by 3. I'm actually finding the cube root. So if you want to find the side is the cube root of the volume. So like here it'd be like the cube root of 8. And that would be 2. Or the cube root, all right, that's GR. The cube root of 10, which I'd have to use my calculator. Wait a minute. Here's the problem. I've got numbers that I can't express, I can't say, without saying the square root of or the cube root of. And guess what? Those are irrational numbers. So let's just back up 1 second. A rational number is a real number, it's not imaginary, you're going to learn about these another time, that can be written as the ratio of 2 other numbers, a simple fraction. For example, 1. Well, that's 1 over 1. Or like 4 over 2. Well, that's just 2. Or 0.66 repeating. Actually, that's just 2/3. Those are rational numbers. I can write them as fractions. Actually, anything repeating is a rational number. I can write it as a fraction. I might have to convert it, but I can do that. You can look at that on Khan Academy too. It's really cool. Anyway, a rational number is also a decimal that repeats Irrational numbers cannot be written as simple fractions. They are numbers that go on forever. There's no repeating process. And often when we use them, we have to use operation symbols or other symbols. Examples would be like the square root of 2. I don't know, what is that number? Well, it is the operation. It is the number that is multiplied by itself and you will get 2. That's what a square root means, right? The cube root of 12. Yeah, again, it's this goofy number that goes on forever. And I'm doing it injustice by cutting it off. Well, I'm just going to stop here. For example, 3.14, that's not pi. That's like a rough estimate of pi. But pi is an irrational number that I cannot write as a fraction. It goes on and on and on forever. So what's the point of this? Let me just get through it and be done. I want you to make 2 number lines. Top one line, use a ruler, even marks, 0 to 10. Bottom number line, same length, 0 to 100 in units of 10. Here's what we're going to do. We're going to put radical signs around all of our numbers. And then we're going to simplify anything we can. So watch. Square root of 0, square root of 1, square root of 2, square root of 3, square root of 4, square root of 5, square root of 6, square root of 7, square root of 8, square root of 9, square root of 10. And the reason we're doing that is because a lot of these numbers simplify, and you will now see like, oh, wait a minute. The square root of 2 is a number between. So the square root of 0 is 0. The square root of 1 is 1. The square root of 2, can't simplify it. Square root of 3, can't simplify it. That's 2. So whenever you see the square root of 3, it is a number between 1 and 2. In fact, the square root of 3 is a little more than the square root of 2. And you can do this on your calculator too. I think we did this earlier in the year. Again, square root of 5, 6, 7, 8, 9. The square root of 9 is the next perfect square, and of course, that's 3. So you can see there's all these iterations between the whole number 2 and the whole number 3. Square root of 5, square root of 6, so on. The same thing can be done, on a scale of 10. So let's do that example as well. Boom, 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 boom. Now, there's only 2 numbers up here that are perfect squares. That's 0, and that's 10, 100. Now what we need to do, it would be helpful if we went back in and just plugged in some other numbers just to give ourselves a sense of scale. And what I mean by that, I'm going to use red. For example, if I had the square root of 9 on here, you would say, well, that's 3. So that would be like right here. And then, of course, 4 would be about 16. 5 would be about there. 6 would be about here. 7's it's really square root of 49, right? 8 would be 64. You can see now we're starting to get a little more space. 9 would be 81. And you can just see how we built another number line. Right? And again, the idea is to give you a sense of these numbers. It is 9 minutes in. That is way longer than I thought, but there's a lot of depth in there. I'll see you next time.